If you see this dimension on a drawing, how would you measure it? If your answer is I just take 2 points and calculate the distance, then stay with me until the end of the video because I'll show you why that approach is not enough. I've been in this field for more than 10 years, and at the beginning I also thought measuring like with a caliper, just 2 points on the surface was enough. Since then, I've seen many people doing the same. Some do it out of habit, some because they don't know better, and some unfortunately to hide the real values. I remember one particular case at a previous job. A supplier came in with the measurement engineer and he told me that I was measuring wrong. His better way was to take only 2 points at the extremities of the part and that's it. I explained that we need to evaluate the entire surface because in reality the whole surface mates with the counterpart, not just the ends. He insisted, but my answer was final. We as a company had the responsibility to make sure the entire surface was within tolerance. That story stayed with me and I thought it would be a good lesson for today's video. So, what are we really talking about? The Independency Principle from ISO 8015. By default, every specification on a drawing must be fulfilled independently of the others, unless a standard or a symbol says otherwise. For example, if we want to measure the diameter of a shaft of 10 mm with the tolerance H7, we can do this regardless of its roundness, cylindricity, or inclination. But, and here is the important part, the size tolerance must be respected everywhere on the surface, not only at 2 points. The same applies if we want to measure the shaft length. The distance must be evaluated across the entire surface, not just at the extremities. Let's take 3 simple cases. If the shaft bulges in the middle or sinks in, we have the barrel or saddle shape effect. This is allowed as long as the deviation does not exceed the tolerance zone. If instead of a cylinder the shaft is conical, we have the tapered shape effect. The tapered deviation is acceptable as long as the deviation does not exceed the tolerance zone. If the cross-section is oval, the ovality deformation must again stay within the tolerance zone. So let me know in the comments, do you understand what the Independency Principle tells us? So don't stop at 2 points. Evaluate the whole surface because every location matters. If you like to see exactly how I approach these measurements in Size Calypso, I prepared an exclusive deep dive video on my Patreon page. There you'll also find a printable cheat sheet for this topic that you can keep next to your CMM and other useful resources. Thanks for watching until the end. If you found this valuable, leave a like, hit that thanks button if you want to support my work, and as always, stay precise.